previous class, about the old republic, because I want to tell people what rootkit is, what a rootkit is about.
Oh.
So I was comparing an operating system with a government, and rootkit is basically members of a mafia infiltrating the government and say, hey, I want you guys, FBI, to investigate these people. Yeah, we'll do it. Yep. Yeah. Sure. Nothing turns out really negative for these guys. Yeah, these guys are perfectly fine. Yeah. That's basically what the rootkit is. And I mentioned, Star Wars because that's basically what the Emperor was. He was a rootkit installed right into the old republic. And then you ended up with worms, called the Death Star and so on. Let's reformat the hard drive. All right, it is time to get started. My recorder should have started already. Yep, it is recording. And we'll get started. Are there any questions from our discussion of conditional statements? No questions? Okay, we'll go through a few examples today in class, so that if you have any questions, this would be a good time to bring up the questions. I will not give you the answers right away. In other words, every step along the way, I'll give you guys some time to think about it. And if you have any questions, about, oh, but what does that mean? I don't think we have seen it before, or something like that. Today would be a good day to ask questions about that. Go ahead and create a new spreadsheet. This is how I would do. I present examples in class. We'll get rid of that. Let's start with something simple, something that we are fairly familiar with, and then we can do this. So I'll say if x equals 2, then z gets a value of 3, else if x equals 5, and z gets a value of 4, else z gets a value of 7, and if. And that's my entire program. We'll trace it line by line. And I don't think we should have any problems with this one. We'll go ahead and trace it with another sheet. This one. Okay. How many columns do I need? Do we have conditions to evaluate in this case? Yep. Every time you have conditions to evaluate, you have to start with a comments column, because I want to know why we make decisions the way we are going to make decisions. So I need a way to to remember. We need one column for line number to tell us okay, where are we at this point? And then we need one for each variable. We have technically 2 variables, but one is really a constant, because once x has a value, it does not change the value. But we still need a column for it. So now we can trace the program. Before we trace the program, the line number has to indicate pre, so that we can indicate what is the precondition of this entire program. In other words, can I assume anything before the program starts executing? In this case, I have to make some assumptions about x, because otherwise there's no way for me to confirm whether x is 2 or 5. So I have to start with some assumption. Let's just start with an assumption that x starts with a value of 5 before the program starts to execute. And I don't know anything about z. I really do not need to know anything about z, because one way or another, we are going to change the value of z as we execute the program. Do we have any questions at this point on row 2 of the spreadsheet? Yes?
Still didn't understand why we need to make assumption of x.
Because if I don't make any assumption of x, and it's a question mark, I will not know, the result of x equals 2.
Oh,
Okay, it's just like when you run a program, an actual program. If you do not know the value of your variables before you refer to the variable to read it, the behavior of your program will be kind of unknown because we don't know, which way it's going to go.
Okay, so we will do another practice rather than 5 later, right?
We can if we want to, but it has to be a particular concrete value for this program to work. Okay. All right. So after line 1, okay, line 1 has 2 things to do. We have 2 things to do here. One is it has a condition to evaluate. X equals 2 is what we need to evaluate on line 1. So I have to say x equals 2 is it true or is it false? It is false because x has a value of 5 at this point, and 5 does not equal to 2. All right. I'm going to do the lazy way, leaving these particular cells blank to indicate neither has the value changed. Are we doing okay with this standard? If I don't change the value, I just leave the cell blank. Yep.
Could I
Question?
just copy and down?
Huh?
Like, I don't want to be lazy. Can I just say it's x still at 5? Can I say that?
You can do that. You can just replicate whatever you had earlier.
So it's correct, not wrong, right?
It is okay. Yeah, it's correct. I'm just saving the file in case you guys want me to upload it later on. Are we doing okay so far with line 1? After line 1, where do we go?
Line 3.
We go to line 3. Very good. We don't go to line 2 because it's a conditional statement. If the condition is false, we cannot take that branch. What am I talking about? What is a branch? A branch consists of a condition and an action. This is the condition for that branch. This is the action of that branch. Except for the last branch, which has no conditions associated with it, because it is a catch-all type of branch. So getting back to the trace, we go to line 3. What does line 3 do? Well, line 3 has to evaluate its own condition. X equals 5 is true. Okay. So if the condition is true for a branch, we have to execute the branch itself. So we go to line. No.
6.
No.
Line 4.
We go to line 4 because the branch is true. Yes.
Just a question on line 1.
Mm-hmm.
Since we know that x isn't 2 and we know it's 5, why isn't z 4 on that line?
Why isn't? Okay. Could you repeat the question, please?
Why in line 1 on the spreadsheet?
Yes.
Why don't, for the z value, why don't we put 4 right now on line 1?
On line 1? Because we are not there yet.
X is 5 and we know that if x is 5 and z is 4.
Well, now we can do it because the assignment is on line 4, so we don't change the value of z until we execute line 4. Okay, that's a good question. We don't change the value of z until we execute the line that has the assignment statement. Okay, very good. Good question. After line 4, yes, go ahead.
If you leave it blank, like saying that line 1, would you mark us down for that? Or?
No, I would not mark you down. That's how I do it in the class. Because later on we'll have a lot more columns, and it will be very tedious to repeat the values of variables. Yep. After line 4, where did we go? We took a branch of a multi-branch conditional statement. So where did we go?
Post.
Post. We are done. Exactly. Very good. Are we doing okay so far with this particular example? Okay. Good. So we'll save this file. Go ahead. Sorry? Row sheet. Very good. I usually forget. I'll start with this side. This time, just initial your name. There's no need to sign it because I want to reuse the sheet for a few times. Yep.
So for the start, the x was given as 5, right?
It has to start with a known value of some kind because otherwise I cannot do the comparison.
Okay, so we just When we start, you're just gonna give us any number. Like,
Correct.
Okay. Good.
You know, if I give you something like this as an assignment, I will have to give you the initial value of x like this, because otherwise there's no way to evaluate the condition of line 1 and line 3.
So there's gonna be something to start with.
Correct.
Okay.
Yep. All right. So this is a fairly simple example. You know, actually simpler than what we have seen so far in the notes, because we have we need to confirm which variable out of 3 is the maximum in the notes, and that's actually more complex as a condition. All right. So I'm going to close this. Don't worry if you cannot copy everything down. Just ask me to upload the file to Moodle, and then you can have everything. This is also being recorded at this point. Let me just confirm that it is recording. Yep. All right. So you have multiple sources to get back to.
Question?
Yes.
Is x, like when you figure out all the numbers, do you save x for last and then you give the value, or does it stay the same?
Okay, let me reopen the second sheet, which is the trace. X starts with a value of 5. It's an assumption that I have to give you. If I give you an assignment like this, row 1 and row 2 has to be given to you, and then you can do the rest.
Okay.
Okay? All right, so let's go ahead and work on a different example. New spreadsheet. And I'll try to make this one more confusing, but it really should not be more confusing. So I'll start with if x is less than 5, then z gets a value of 1, else if x is less than 7, then z gets a value of 2, else if x is greater than 0, then z gets a value of 3, else if x equals, I don't know, let's try 4, then z gets a value of 4, else z gets a value of 5, and if. All right. That should look fairly confusing. But remember, it's not. In other words, this particular example is designed to differentiate whether you really understand how multi-branch conditional statements work. If you look at this code and know, yeah, I can figure this out, no problem. I know how to figure it out, you're getting the concept. If you look at this and go like, well, I don't know, it seems like the program can do this, but it can also do that. That means you have to kind of revisit and think about how a multi-branch conditional statement works. Let me save it first before I forget. I'll just simply call this conditional 2 and open up a new window to trace it. Okay. All right. And this time I'll give you several traces too. The first one being really the obvious one, and then the second one starts to go like, well, that looks kind of confusing. Okay. Starting with comments, because we have conditions to evaluate, line number, and then we have exactly 2 variables, x and z, just kind of like last time. I have to give you a precondition so that x starts with a particular value, and as promised, I'm going to give you something that is really obvious. X starts with a -10 value, and z starts with an unknown value. Whatever z starts with is going to be overwritten anyway, so it doesn't really matter much in this case. On line 1, we have to evaluate the condition of line 1. X is less than 5 is true. Okay, so where do we go?
2.
We have to go to line 2 because we are following this branch. And line 2 is going to do something to z, isn't it? Z will become 1, and then where do we go next? Post. Post, because if it's a single multi-branch conditional statement like this, you take one branch, you get out you get out of the entire statement. Are there any questions at this point about this particular case? Yes.
Wouldn't, in
this case x equals 4 be a redundant branch because it would have posted before it ever got there? 'Cause
Well, you take
4
one.
is less than 5,
Correct.
so it would post before it ever got there. And
That's-
z would be 1 and not.
That's what we will illustrate. Okay, that's one of the confusing ones. Okay. In fact, 4 would also fit into this case, and also this case, and also that case. But it doesn't matter because once you take one branch, you just get out. You don't even have a chance to evaluate the conditions of line 3, 5, or 7. Okay. So let's go ahead and take a look at another test case. And let's say in this particular test case, x starts with a value of 20. Okay, this is also an easy one. Pretty clear cut, pretty easy. All right. So on line 1, we evaluate the condition again. X is less than 5 is false. That's easy. Where do we go next?
Line 3.
Line 3, because if the condition of one branch is false, we go to the next one, okay? Whatever is right below that. So we go to line 3. Line 3 has another condition. X is less than 7 is false. All right, very good. We go to line 5. Line 5 is saying x is greater than 0 is true. Then where do we go? Line 6, because we are taking that branch. Z gets updated to a value of 3, and then post, we're done. All right, this one is pretty clear cut too. Okay. And then we'll go for one that is not so clear cut. But it should be. In fact, just like what you said, we'll use 4, because 4 is an interesting one. All right, this one is confusing because, well, it can be, it should not be, but it can be confusing. Because on line 1, we evaluate x is less than 5, it is true. Where do we go? Line 2, and what does it do? It changes the value of z to 1, and then what do we do? Post. That's right. So that's interesting because if you think about it from the visual, just looking at the code perspective, what about line 3? X is 4, 4 is less than 7. What about line 5? 4 is greater than 0.
They're all true, but I imagine that if the first one you told you that would work, you just take that branch.
Exactly. We take the first branch. We took the first branch. When we are done with line 2, we get out of the entire conditional statement. We did not have a chance to evaluate line 3, 5, or 7. Question?
Does that mean that the code is somehow wrong?
No, the code is not wrong. It depends on what the intent of the code is. But since I did not tell you the intent of the code, we cannot mark it wrong. Yep.
I understand the code for 3 and 5. I just don't see what the code for line 7. There doesn't seem to be any purpose for that because if it equals 4, it will never get there.
That is a very good observation. The observation is there's no purpose to line 7 because if x does equal to 4, it will satisfy line 1 already. Okay, not even 3 or 5. Okay, that's very good observation. So if I wanted to ask you something to make sure that I can see that you understand what a multi-conditional statement is and how it behaves, I can reverse my question. I can say, let's think about the cases, the branches. Let's think about line 2, 4, 6, 8, 8, and line 10. And I can reverse the question and ask, how can I make that particular line execute? Okay? And you have to tell me the initial value of x in order for line 2, 4, 6, 8, or 10 to execute. Okay, let's try it. Can I make line 4 execute?
Yes.
What would be the value of x? Just give me one example.
6.
Yeah, if x equals to 6, then the first condition will fail, and it has no chance but to evaluate the second condition. The second condition, x being 6, 6 is less than 7 is true, it executes line 4, and then we get out of the conditional statement. What about line 6? Can we make that happen? We just made it happen,
Yes.
didn't we? 20, yeah. Okay, lots of values to make that happen. What about line 8? There's no way we can make it happen.
No.
This branch is useless, okay? It's not incorrect in the sense that it doesn't really make, it's not a mistake, but it is also useless because it will never execute. What about line 10? Can I find a value that is not less than 5, not less than 7, not greater than 0, and not equal to 4? No. So line 10 is also useless because we will never get to line 10. Okay? Now what if I change the ordering of the branches? That can change the behavior of the program. If I move, if I move these two lines to become the first condition, then the behavior of the code will change. So the ordering is very important in this case. Are we?
Immediately.
Sorry?
I said the program would end immediately because most numbers.
Depending on what x is, yes. Depending on what x is, it will end immediately. It can.
You're actually making the code worse if you put that first.
Yep.
I mean, as it is currently, 3 of them are valid. If you put that first, only 2 of them are.
Not valid, reachable. It's we call a branch reachable when it is possible to, in a particular case, to execute that code.
Technically, it's valid as long as the code is correctly syntaxed.
Yeah. Well, it does not cause any execution problem, but it does execute. But in this case, they don't even execute. We have special names for these two branches. Can anyone kind of guess what those names are? What that name is? It's called a dead branch. Just like a dead branch in a tree, it's called a dead branch because that branch will never get a chance to execute. But what kind of programmer will write programs like this? I mean, that seems just not very smart.
Half asleep.
Half asleep, not enough caffeine. Well, that's not actually the case. Think about tax code. Okay, think about the United States IRS tax code. Are there a lot of different conditions depending on your income, your various status, and so on and so forth? Do you think there will be cases where if they do not specify which order to evaluate, there will be multiple rules that can apply at the same time, and the rules can be conflicting?
Yeah.
But what does the how is the tax law written? It tells in order. It tells you the order, right? So it will tell you that, okay, check if this applies to you first. If it does apply, this will be, what you need to do with your tax form, and do not follow those other steps. Skip to section da 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 da. And it's doing exactly the same thing here. Okay? This kind of coding, or the effect of this kind of coding, can happen when a program has been growing over time and different people have been extending or changing the logic. So at some point, this may not look this simple. In other words, this condition can be like this long. Now, how can you make sure that conditions this long do not overlap with a previous condition? It's not easy. Okay, there's a way to do it. You can use a truth table or some other tools to do it, but it's not easy for sure. Okay. So are we doing okay so far with this example? That we established that some of the conditions or some of the branches are what we call unreachable. It's there, but we will never be able to get there. All right. So with that, we are done with conditional statements, and it is time to move on to loops, which is a lot of fun. Yay. Because we can possibly not get out of something when we have loops. You're supposed to have read the loops module. I call this a module. So instead of just reading the module, I'm going to give you examples, and then we'll work out the examples. And then from time to time, I can probably go back to the notes just to refer to a picture or so things will be easier. Instead of presenting repeat until first, I'm going to talk about while first, because that's also the confusing one, because we just talked about conditional statements. So now with a while, it will look like, hey, they're about the same thing. they're not. All right, so we'll go ahead and do a fairly simple loop. X is less than 2. Let's make it confusing. Let's make it very confusing like this one. While x is greater than 1, do x gets x minus 1. And while there we go. Save it. And we'll call this while 1. And we'll trace it in sheet 2. We need comments because a loop also has a condition to evaluate. It has line number, and we have one single variable. In this case, it is x. The precondition is, well, you can put anything here. It doesn't really matter. Why doesn't it matter what this particular cell has? What does line 1 do? Exactly. It overwrites the value of x right away. So whatever you assume x had, it really doesn't matter because we're changing it right away to 0. So for the purpose of this particular exercise, I'll just say it doesn't even matter. I don't even need to know it. Line 1 is pretty easy to track down. It just changes the value of x to 0. Line 2 evaluates the condition. X is greater than 1 is false, right? And then what do we do? Well, here, this is what we need to remember is what is the meaning of while? Okay, if you want to find a normal everyday phrase to replace while, the closest one I can find is as long as. Okay, as long as x is greater than 1, do x gets x minus 1. So we decrement it so that eventually it will be not greater than 1 anymore. So according to that semantic, that meaning of what while should do, where do we go next? Post. We're done. Okay. So that's my first test case, the first program. Do we have any questions about this? Yep.
What is meant by the line 3s?
Line 3? Line 3 is x gets x minus 1. We evaluate the right-hand side first, which is x minus 1, and then we store the value back into x. It is an arrow on the...
I thought it was like between the x and the 1, but...
Oh, okay, that's just a minus. Yep. All right, so this one doesn't seem too hard. And then we'll go ahead and save it as a different file name so that we can test something else. So this time I'll change, greater than 1 to less than 2. Okay. And then we'll try to figure out what this one is going to do. Okay. We can start with the same condition or precondition, because the first thing we do on line 1 is to overwrite the value of x. So we don't really need to know its precondition value. We start on line 1 again. X gets a value of 0 again. Now we go to line 2. Line 2 behaves a little bit differently this time. X is less than 2 is true. And just like with a conditional statement, when the condition is true, we go into the code. And where do we go next?
Line 3.
We go to line 3. 3 is going to... I need to modify this program, otherwise we'll never get out. Okay, so I just changed line 3 so that instead of decrementing, it is now incrementing the value of x. X currently has a value of 0. We evaluate the right-hand side first. The right-hand side says, we want to know what is x plus 1. X is 0. 0 plus 1 is 1. And then what do we do with the value 1? We store it back into x. So x is now updated to a value of 1. Are we doing okay so far with this step? The big question is, what do we do next?
You go back to 2.
We go back to line 2. That's the difference between a conditional statement, which is quote unquote one shot, versus a loop, which means, hey, you got to go back and do it again until the condition is not true anymore. Because while is implying as long as, you know what, x is still less than 2. So, but the behavior of the code is at the end of a while loop, you always go back to the condition of the loop and reevaluate what it is. So we still have to reevaluate the same condition. X has a value of 1. 1 is less than 2 is true. Then we go to line 3 again. Line 3 is going to do the same thing, except the value of x is now 1 and not 0. So when we evaluate the right-hand side of the assignment on line 3, which is x plus 1, we are adding 1 to not 0 anymore. We're adding 1 to 1 for a result of 2. The sum is 2. What do we do with the sum of the right-hand side? We store it back into the left-hand side, which is x. So x is now updated to 2. Okay, well, Tech, I can see right away that x is no longer less than 2. Let's call it post right now. No, we cannot do it that way because
You have to state it false.
exactly, we have to go back to line 2 first, because that's how the program executes. We go back to line 2. We evaluate x is less than 2. It is now false. Then we go to post to say that we are all done. But Tech, isn't that one extra step that we did not really have to take? Because I can clearly see that x had a value of 2. 2 is less than 2. It has definitely false. Why do I have to trace line 2 again?
Because the computer can't see it.
Exactly, because that's how your program will behave when you write something like this in whatever language. You can write a program in C, in Java, in Perl, PHP. They will all behave like this. It has one last execution of line 2 before it actually gets out of the loop. Now you might think that, but that last execution really doesn't matter because it doesn't change anything. It doesn't change the outcome of the program. Why do we have to do it this way? Why are you so picky? I don't like it. That's what my kids say. Well, there are some cases where that one last evaluation of line 2 can make a difference. It depends on whether the condition of line 2 has what we call a side effect. This one has no side effect. In other words, evaluating whether x is less than 2 or not doesn't change anything. But potentially, if you have this in an actual program, you can potentially, when you evaluate a condition, at the same time it can change something. So in those programs, whether it goes back to line 2 or not actually makes a difference. And that's why we have to be picky in this class, because we want to model exactly what the program will do and not just, but we just want to get to the destination, right? It's not the journey that is important, it's the destination. It's actually both in this class. Okay? I'm not particularly picky, I'm just as picky as the computer. When it comes to the behavior of the program. Now when it comes to the syntax, I'm flexible. Okay? If you guys want to spell out 2 instead of writing the numeric 2, I'll take that as a right answer. No problem. As long as it's written in a language that I can understand, it's okay. Are there any questions about this program? But Tech, where in your notes am I supposed to read about this? I mean, you never mentioned that in the class. Well, it's right here. So if I go to this note here, there's a picture of a generic condition, a while loop. The generic picture of a while loop looks like this. I know it looks more like a biology class now. You have the stomach and stuff like that. The good thing is we don't have a loop in our digestive tract, unlike some other animals. Yeah, some animals have an external loop in them. We don't want to talk about that. Bunnies. Okay, but this is a good picture because it clearly shows the paths when we have a pre-checking loop. Oh, but Tech, we never talked about what a pre-checking loop is. A while loop is also called a pre-checking loop because the condition is evaluated before the action. So in this case, we have the logic of eating. Okay, So you always come in from the north, okay, coming down here. Now it looks like we have a branch right here, but that's not a branch because you can see that each path is also only going in one single direction. So that means with this branch here, okay, coming in from this branch, it can only come in, but you cannot do it like this. You cannot get out using this path. It's only coming in. So when you're first coming in, you have no choice at this point until you get to here. Then you have two paths that you can take. One path can lead to this action. The other path will take you all the way out to the next statement. Whenever you have a branch, what do you expect? Whenever you have your path splits into two, and you can take either one. Sorry?
You're gonna take either. You're gonna pick one.
How do you decide which one to take?
Based on the condition.
Based on the condition, which is a question, right?
Right.
So in this case, the question is one not full? Okay, still hungry. If the answer is true, then that person will take another bite. If the answer is false, it is false that this person is not full, which means that person is full. Then you will take the other branch and then get out of the entire loop. The biggest question is, what do you do after you take a bite? You go back through this path, and then you go back to before the branch, and then you can ask the question again, and then depending on the answer to that question, then you can decide all over again whether to take another bite or to get out of the loop. That's the behavior of a pre-checking loop. The name pre-checking loop comes from the fact that the condition is presented before the action. That's why it's called a pre-checking loop. Are there any questions about the pre-checking loop? Yep.
This is kind of off topic, but I noticed when you open a new tab, I don't know if you know this, but if you use the middle mouse button to click, it'll open the link in the new tab. And you can also use it to close the tab. You can just click anywhere with the middle mouse button.
Cool. Thanks. Yeah, my kids, ask me, how can you use a track point to play, base wars in, Roblox? Sometimes I just use really archaic ways of doing things, but thanks, I'll try that.
You can also scroll through the tabs, like if you move your mouse up to the tabs.
Mm-hmm.
I don't know if that's just an Ubuntu, but you can, if you use your scroll wheel, you can scroll through.
Yep. Yep. That works too. Shortcuts. It would be helpful to me if I could think that fast. Some people ask, Tech, how come you type so slow and you talk even slower? I cannot even think that fast. I mean, I can talk fast only if I can think faster than I can talk. Okay, that's my bottleneck. Has anyone taken a class from Carol Lever? She's probably one of the fastest talking professors that I have seen. That's because she can think fast, but I cannot. I know I'm digressing here, and that's why I'm so slow. I have a buddy who works for the Lawrence Livermore National Lab, and sometimes he would play different types of games with me, like chess or the Go game or some other card game, and it takes me a long time to think about the next move. And he would say, I can hear the the mill or the grind. I can hear the grinding sound of the mill, like that. Yep. That's how slow sometimes I am.
That's how you're supposed to play chess. That's how you're supposed to play chess.
Or Go game.
He can't help you run dial-up. He said he can't help you rate on dial-up.
I can type as fast as just about as fast as 300 BPS. All right, enough digression.
I think that went over everybody's head.
But are there any questions about this particular picture? This is a very important picture because what you need to do is to map this picture to the pseudocode. That is what you need to do. This code here is expressing exactly the same logic as this picture here. Okay? So what you need to do is to, in your mind, when you see the pseudocode, you have to remember the behavior of the pseudocode. That's a pre-checking loop. Doesn't it tell you something about a different kind of loop? If I call this a pre-checking loop and not just the loop, that means there has to be another type of loop called a post-checking loop. Okay, a post-checking loop will check the condition after the action. So let me save this first, and then we'll use another example to illustrate what a post-checking loop would behave. And this one can be misleading. Okay, so I'll do something that is potentially misleading. X gets initialized to a value of 6. Repeat, x gets x minus 1 until x is less than, say, 8. Okay. It is intentionally confusing. Or at least the looks of it is intentionally misleading, but it's not. It should not be misleading. I call this repeat 1. And we'll trace it in sheet 2. Same setup. We have a condition to evaluate. X is less than 8 is a condition. So we need one column for comments, one column for line number, and one column for our variable x here. And since on line 1 we are overwriting the value of x anyway, we can just say that, hey, we don't need to know anything about it. And then we'll trace the program. Line 1 is going to change the value of x to 6. That's an easy one. And the funny thing is we don't trace line 2. Line 2 serves no purpose other than marking the beginning of the post-checking loop. And if I have a line that has no other purpose than to mark the beginning or the end of a particular construct, I don't trace it in the pseudocode because it doesn't do anything. Okay, I'll just be wasting a row on sheet 2 if I were to trace line 2 of the pseudocode. So I don't even bother with that. I go straight to line 3. Okay, what does line 3 do? It subtracts 1. Okay, we evaluate the right-hand side first. X has a value of 6 right now. 6 minus 1 is 5, and then we store 5 back into x. So as a result, x is updated to a value of 5. Then we go to line 4. Line 4 evaluates x is less than 8. Is that true? Yes. It is true. If I don't give you the trail map or the logic, can you figure out what we should do next? Post, right? Because that's the meaning of until. Because when you say repeat, do something, something, something until a condition is true. Let's say circle around in the parking lot until you find a space to park. Okay. So what do you do after you find a space to park? Do you still circling around in the parking lot? No, you just park. Well, you get out of the loop and then you park and then you get out of the car. Okay. So the condition after the word until is also called. It's called a terminating condition because it stops or terminates a loop. That's how you get out of a loop.
Okay. So what's the difference between the and while and until right here in this example?
It is the order of the evaluation that matters.
Okay.
Okay, if you look at this code here, why do you think I said it is confusing?
Yes, because it ends right away. There is no.
Exactly. Because if I were to do this, using my superpower IQ, and I say, hey, on line 1, after line 1, x has a value of 6, and it's less than 8 already. Post. Would that be right? No, because I was reading it as a human. But the program, or when your computer executes code like this, it always do it like this. In other words, it is called post-checking for a reason. It always performs the action before it evaluates the condition. Just like what it's doing here, because it's executing line 3, regardless, even though 6 is already less than 8, it didn't know at this point. Okay, it has to execute the action first, then it has a chance to evaluate the condition and realize, oh, okay, I guess it's time for me to exit already, and then it just gets out of the loop. And obviously, I prepared a picture for that as well. I don't know whether the pictures are helpful or not, but
Yes.
yes. So here is a picture. Oh, I did a thing. I mean, my right-click instinct is just too strong. It's like right-click. Okay, this is the equivalent logic. I can present the actual code. Let me look at that code. Did you open a new tab? No. That didn't work. Could be the mapping of the buttons. Maybe the middle button is mapped to something else. It's usually paste. In Linux, the middle button does paste what we usually refer to as paste in DOS. That's okay. Big deal. Okay, this is the pseudocode. Repeat, take a byte until 1 is full, and then this is the picture representing that. In other words, if you look at the picture, we come in from the north, but we don't have a branch here. This is not a branch because it is a one-way street. So we have no choice but to go to the action, take a byte, and then after we take a byte, there is a branch here because we can proceed to get out of the loop, or we can also go back to an earlier step. It is only at that point that we ask the question, is that person feeling full? Because if that is true, then we get out. If it is not true, then we have to go back and take a bite. Here's the question. What if that person is already stuffed to begin with before coming into this logic? I will refer to the meaning of life. Monty Python. Because that person will have to take a bite first. But in that case, may not have a chance to ask this question because it would be an exception. Throwing an exception and like that. Yep. Monty Python. Yep. Great stuff. That's usually a good test of what is the average age of my class, because a lot of people do not know what is Monty Python. Yep.
So if 1 is already full, do we still take a byte?
Yes, because we cannot check that condition until after a byte is taken.
Okay.
Okay, and that's why it's called a post-checking loop. The action goes first, you ask the question next.
Okay.
It's post-checking because you check the condition after the action. Yep.
As far as the pseudocode is concerned, do the while and until matter? I mean, I realize that the placement of the while/until is what makes it a pre/post loop.
Mm-hmm.
So if you put while afterwards, does that make it a post loop?
Okay, that's a good question. The question is, can we use the word while and still retain the property of a post-checking loop? That's basically what you're asking. The answer is yes. I'm going to illustrate it, but I do not use this construct in this class because I think repeat until makes more sense to people than do while. What he is asking is, can we do something like this instead? Do take a byte while 1 is hungry. Okay, to express the same logic as the other code, right? And the answer is yes, you can actually do this. In fact, this is the only thing you can do in C. But I don't use do while because it is less intuitive from the standpoint of pseudocode, because we use the word until more often than while or as long as. So that's why, and also using this while format can also confuse people because we have now while do and then do while, and it leads to more confusion. If I use repeat until, then they look completely different. So that's a good question, but in this class we just use repeat until. Very good. Are there any questions about repeat until versus while do? Which one should we use? Depends on what you're doing. Very good. So I have an example to illustrate which one we should use. What about data validation? In other words, let's say I'm writing a very dumb program. It prompts you for a zip code, and it will come back and ask you again, but only if the zip code you provide that you type in is invalid. Okay? So we want to express that logic. And I'll just use a little text editor here to illustrate it. Okay? So I have two versions of this. The first version is while zip code is invalid, do ask user to input zip code, and while. That's version 1. The other one is repeat. Ask user to input zip code until zip code is valid. Okay. So when you look at these two pseudocode, they seem to do about the same thing. Both will get out of the loop when the zip code is valid. Because the first version, the one that is highlighted at this point, is saying as long as zip code is invalid, ask the user to input again. So it's definitely a loop. If a user keeps on typing an invalid zip code, it will keep prompting the user over and over again. The second one seems to do about the same thing. Repeat, ask user to input zip code until zip code is valid. But in reality, if you're writing a program like this, which one should you use? Which one is not going to work? You would use repeat because the first version, in the first iteration, what zip code are you validating? It's not something that the user input. Okay? You might have an initial value somewhere. You might have initialized your zip code from somewhere, but it's not something that the end user input. In the second version, the first thing you do is to ask the user to input something. Then you have something to validate. And it makes more sense in this case. Okay? But tech, I'm pretty smart. I can make the first one work just like the second one. Because what I can do, is copy and paste. And now they work exactly the same way. Right? Asking the user for the input first, then I have something to validate. And the answer is yes. Now these two programs will behave exactly the same way. But do you guys remember what I said like in the last or the class before last? Every time you copy and paste, you have to ask yourself, is that really necessary? Is there a better way to do it? What did I just do? Copied and pasted. Okay? So that means the first version is not as good as the second version. Why? Okay, it's not as concise. That's one.
More code.
It's more code, but there's one bigger problem. What if I want to change the logic and instead of inputting, zip code, I want the zip +4 code. Okay. In the second version, I have one place to do it. I'm done.
When you have two.
Okay. In here, I have two to make it consistent. If I forget to fix one, nobody's going to remind me that I just copied and pasted, and there are two copies of code to do it.
A zip +4 code is going to be invalidated.
The validating part, yes, that has to be changed as well. But nonetheless, this version still has one more place to fix than the other one. What if this code here is really complicated and long? What if this is 20 lines all by itself? Then I have to copy and paste 20 lines. What are the chances that I might need to change one of those 20 lines? Higher than when it's only one line, right? So that means the copy and paste approach may seem attractive and feasible, and nothing is wrong with it when your program is relatively simple and small. But as you scale up and your program gets more complicated, copy and paste will eventually become less efficient. Yep.
I have a question. Is what you're reusing your code from another program, is it then okay to copy and paste if using a similar bit of code?
That's a good question, but the answer to that, unfortunately, may involve something that we haven't talked about. It depends on whether there's a subroutine already established that you can share with the other program.
Okay.
And your question?
To prevent going through and changing it all by hand, instead of doing the easier route, version 2, couldn't you also redefine zip as zip +4?
You can also, well, that's a different one.
Before entering the loop.
That is a good way to do it, but that involves object-oriented programming concepts because you're changing the type of the input, and that's something that is related to object-oriented programming. Because in this class we barely talk about types. We don't really get into object-oriented programming, and that's why we like object-oriented programming, because you can do things to simplify your program a lot. Yep, that's a good point. Okay. Do we have any questions about loops and conditional statements? Okay. What have we covered up to this point? We have covered assignment statements. Okay. Now those are the only statements that can change the value of a variable. So they are really the basic steps of programming. Then we talk about the sequence, because if you have 5 assignment statements, the order of the assignment statements matter. Okay, which one you execute first, which one is the second one, it all matters, because if you change the order of your statements, the outcome will change as well. But the sequence is relatively simple to understand. It's just a straight line like that. Then we talk about branching. Okay, you come down and at one point you say, oh, there are 2 ways to proceed. Which way should I go? Well, there has to be a condition, which is a question. Depending on your answer, which is either true or false, you follow one path or the other. But the 2 paths will eventually merge and become one path again before you proceed to the next statement. And then today, we just talked about the 2 kinds of loops. We have the pre-checking loop, which means you check the condition, then you decide whether you want to do something. In some cases, you may not do it even once because the answer is false to begin with. Then we have post-checking loop, where you always perform the action first, and then you ask, should I go back and do it again? Well, sometimes yes, and sometimes no. We are done with control structures. In other words, as far as controlling the flow of a program, we are done. Okay? Everything else, okay, in most practical programming languages, they have switch statements, they have other types of statements like for next loops and stuff like that. They can all be emulated by these basic steps or basic constructs that we have talked about. So we are done with control structures. It really only has 2. It really only has conditional statements and loops, 2 main kinds. And that's it. So what are we going to do for the rest of the semester? Good stuff. Trust me. We have a lot of topics to cover.
Are we going to go backward, like give you the result, and we have to write down all the performance?
In this class, you are not going to write your program. In other words, you're not going to design your own program. You will be tracing my program all the time. I write the code, you guys tell me what it is going to do. Step by step, line by line, in the trace.
Toothbrushes.
Huh?
It's time to get out your toothbrushes.
More like a pick in this case. It's better for scrubbing pick. Like that. But in a way, it is very beneficial because a lot of people can, I have seen this not only from a community college. When I was a TA teaching assistant at UC Davis, when I was a graduate student, I have to go to the computer lab to help out the students. That's part of my responsibility. So there will be times at 9 p.m. since I live in a dorm, I can pick a really late time to go to the lab. And the equivalence of our cisp300 class, because I was a TA for that class, I would see students trying to fix their program that is due the next day, and they try to debug their program. Instead of sitting down and logically looking at the program and say, okay, this is a program that I write, that I'm writing, okay, I should know the behavior of the program. I should be able to look at this line by line. I can track it down and understand what it's doing. They are in a panic state to fix the program so that it works. Can anyone imagine what people would do? Yep.
You just change something and see what happens.
Yes, they will just randomly make changes. Now, I wouldn't call it random. They will change a greater than comparison to greater than or equal to, run the program again. Oh no, it's still not working, they're doing what it's supposed to. But instead of reverting back to the original, they forget that they have just made that change. And then they change, like comparing to 0 to compare to 1, all the little tweaks. Oh, what if I change the order of these 2 statements? Copy and paste, put it there and so on and so forth. And before long, what do you get? Spaghetti code, right? The spaghetti flying monster will be honored. The flying spaghetti monster, FSM. And is that helpful?
No.
Do you think they turn in anything that will give them points?
No.
No. If anything, it will be worse than before, right? Before they make these random changes. But why do you think I brought that up?
So we don't
This class gives you the tools so that you can just look at a program and you know exactly what it is supposed to do. Okay. Without this class, I mean, there are other professors who teach P300 differently, and they start right off with Visual Basic or some really simple programming language. But I find that in those classes, there's a tendency for people to just run the program to find out what it is supposed to do, instead of looking and reading the program analytically to find out in their mind, go like, okay, I think I know what this program is supposed to do. But instead of doing that, they just run the program and then print out the variables at the end. It's like, okay, now I know what the program does. Well, only for that input, for that particular test case. But what about in general? What is the program supposed to do? Well, give me a test case, I can run it again.
Run that debug function in Visual Basic and know which line is crashing, but don't know why.
Yep. Don't know why, and not having the tools to go back in time to track down what went wrong is a big handicap. All right. Now this one is about nested statements. Okay, nested statements. What exactly are we talking about nested statements here? Well, to understand what a nested statement is, or the concept of nesting, or having something to contain something else, let me present this particular analogy. How much is a 2 terabyte hard drive now? From Fry's, whatever, doesn't matter. $100?
Yeah, maybe.
Not even? Okay, so storage is cheap, inexpensive. Okay, and I know that your cameras are getting bigger files too, because we have 18 megapixel cameras now on a little point and shoot. I still remember the days when I had to pay a lot of money for a 10 or 11 megapixel camera. It's like, wow, that's almost like a car. Now you can pay 70 or 80 bucks and get more pixels than I did back then. So files are getting bigger, but still, even with big files like that, 2 terabytes can store a lot of pictures. Okay, so imagine this. Microsoft one day just decides, we don't need structure. You guys don't need subdirectories. I'll give you one directory, C:\\, and that's it. Okay? Does everybody understand what I just said?
Yeah.
No? Okay.
This is basically the first, right?
When you go into a file system, this it's not even dependent on the operating system. I'm just using this as an example here. Okay, this is my home folder, and you can see that it has these little subfolders here, and each one has its own files. And some subfolders has even other subfolders, like this one has additional subfolders, and then the subfolders have files. So I'm talking about the concept of being able to create a folder and being able to put folders inside folders. Okay. What if Microsoft one day says, you don't need that. We don't need subfolders. I'll give you the \, which is the top level folder, and that's it. Every file has to go there. Go ahead.
Does the length of the file name matter at that point?
Let's even say that you can have, huge, long, big file names.
Then that doesn't matter. You can just name the file and make your own subdirectories via the file names.
Functionally, yes, you can do that. But when you try to look up a particular file, what do?
You search for file name, and then you use your pre-made, your subdirectories to search for this subdirectory, that subdirectory, and then your file.
What if you forget what subdirectory you put for a certain file?
Yeah.
Then you're screwed.
Yep, exactly.
The more important the file, the more probability it's going to get lost.
Exactly. And when you open a file, remember when you go to Microsoft Word and you want to open a particular document, now you have 20 gazillion files in one single folder, and you have to pick one of them. Let's say that you have perfect memory and you know exactly what file name you're trying to pick. Unfortunately, the file manager interface does not let you type the name. It only gives you a scroll bar. Okay, so now you have a scroll bar. There are not enough pixels on your screen, 1 pixel to represent one file, right? That would be bad. Okay, that's why we need structures, right? Being able to have a folder inside a folder inside a folder. That's what I'm trying to illustrate here. Nested statements is doing exactly the same thing. It means you can have a statement inside another statement, inside another statement, inside another statement. That's all. Okay? So remember the analogy, because every time we talk about a new concept, I typically would give you a reason why we have that feature, and you have to remember the feature more so than the detail of the feature itself. Because if you remember why we need it, you will remember how it works. All right. So here's a simple example. Now, as simple as an example, it's already illustrating the concept of nesting. Because if I ask you how many, statements we have here, what would be the answer? Line 1 obviously is a statement on its own. Line 3 is obviously a statement on its own. What about the while thing? Line 2 to 4 is also a statement. It is already nesting because line 3 is a statement within the pre-checking loop. So as soon as we started to talk about conditional statements, we have been using the concept of nesting already. I just did not say it. Now, why do we need that indentation thing? Sorry, go ahead.
I said sneaky.
Well, I'm just, I don't want to mention too many things at the same time. It's only in due time, right? What about line 3? How come line 3 has some empty space in front of it?
To designate that it is nested within something.
Exactly. It's just like when you use a file manager, when you look at, a folder containing a folder containing a folder containing files, you have the staircase, the reverse staircase, look of it. And this is exactly doing the same thing. So the indentation of line 3 is used to indicate which statement is inside which other statement. The tag, it is so obvious that line 3 is between while and end while, and therefore it is nested inside the conditional statement, inside the loop in this case. But it may be easy to tell here, what if the while loop has 20 lines inside the whole thing, and within the 20 lines we have other types of nesting already. It may not be so easy to read in that case. Let me see if I can give you some example of why indentation is useful. And all we have to do is to go to Wikipedia and look up some relatively complex algorithms. So we'll start with bubble sort. Bubble sort is a very simple sorting algorithm, but it is already a lot more complex than what we have seen so far in this class. That's bubble sort. You can see that our pseudocode resembles actual Pascal code quite a bit, okay? Because we can actually read this for the most part. Now, not even caring about what is a for loop and stuff like that, we can see the nesting. We can see one nesting level is procedure and procedure. We haven't talked about subroutines yet, so forget about that part. It's not important. But what we do know is it is some kind of a container. It is containing whatever has a second level, has the next level of indentation. And then what do we do? I mean, what do we have? We have a repeat until. We have a if and if. We also have in between a for and end for. Now, this is where I said, don't worry about the for loop because we can do everything with just while and repeat until. Okay, but you can see that how statements can be nested in this case. What is also interesting is we have this statement having the same level as the for loop. They're actually at the same level. In other words, this statement gets into the repeat until loop, but it is not a part of the for loop. It is outside of the for loop. Okay. Without indentation, this will be a lot harder to read, because without indentation, you will have to find the words. Your eye will have to scan. When you want to find the end of repeat, you will have to find until. But if all these lines start from the same column, it'll be harder, much harder. And that's why indentation is useful. When you write programs, here's a question. It's not a fair question because most of you have not programmed before, but I'll just ask that question. Do you think the compiler need the indentation to tell which statement is inside which other statement?
No.
For the most part, no, because unless you're programming in Python, the indentation has absolutely no meaning to the compiler, which is the tool that you need in cisp300 in order to run your program. So that means you can write your entire program on one line. Yes, it will be a long line, but the compiler doesn't care. Would it be easy for you to read? No. Okay? And in some classes, I would not name which class or which professor, if you use the wrong type of indentation, you will get marked down. Okay? And it's not without good reason, okay? Because if you do not use the right indentation, it's a habit that you can get away with when your programs only have 50 lines, even 60 or 100 lines. Some people can keep track of their programs pretty well without indentation. What if your programs have hundreds of thousands of lines, which is
closer
even
to like a web browser size program?
Yeah. Can you keep track of the logic without indentation in that case? It'll be much harder, okay? I wouldn't say impossible, but it is much harder in that case. So that's why indentation is useful. It is a visual way for us to tell which statement is inside which statement. This is too simple to really talk about. We'll start with this one. It's still not very complex. It has one loop inside another loop. We have about 9 minutes left. We'll get started with this one. We'll probably finish it on Thursday. So let me go ahead and get it started first. There are only a few places where it is really important to talk about. For the most part, a loop is a loop, an assignment statement is an assignment statement. So we'll go ahead and start tracing it. And we'll see how far we can go today. Do you guys want me to do it without indentation so that we can kind of experience how difficult it is without indentation?
That's fine.
All right, so that's basically the program. When you do this in Calc or in a tool like this, it's really kind of handy because I can do something like this. Let me say first. I'll just call this nested. Because I can just select whatever is in between while and end while here and indent the entire block. That's a really helpful tool because in two steps I can now I have just indented the program correctly. All right. So here's the program. Should we save it again? And we'll go ahead and trace it. So as usual, because we have conditions, whenever we have loops or conditional statements, we have conditions to evaluate, and then we need comments so that we can document why we make decisions in this program, how we make decisions in this program. We have line number, and then we have 4 variables in this case. We have x, y, z, and a sum. So we have 4 columns for our variables. And then we'll go ahead and get started. Precondition is we don't need to know anything because every single variable will be overwritten before we need its value. So they can all start with unknown. Line 1 is going to change x. X gets initialized to 0. And then line 2 is going to change our sum to 0. And then line 3 is a while statement. We have to evaluate the condition. X is less than 3 is true. So where do we go next? We go to line 4. It seems natural that we go to line 4. So far we don't need to really explain anything. After line 4, we go to line 5. It is another loop. It evaluates y is less than 2. It is true. So we go to line 6, right?
Yep.
Okay. Line 6 is adding 1 to y. Y goes from 0 to 1. Then we go to line 7. Line 7 wants to add up everything. So we have 0 plus 0. Oh, we don't have a z, so never mind this column. Just delete the column because we don't have that variable. So what is 0 plus 1 plus 0?
1.
It's 1, and then we put it back into sum, which is 1. Now we have our first question. Where do we go next? Now we know that we are at the end of a loop. In fact, we are, okay, wait, hold on a second here. Let me rephrase that question. We're at the end of what? Are we at the end of one loop, or are we at the end of two loops? We're only at the end of one loop, so where do I go next?
The beginning of that inner loop.
I have to go back to the beginning of the loop that is currently ending. Which loop are we talking about? Are we talking about the loop from line 5 to line 8, or the loop from line 3 to line 10? Line 5 to line 8. At the end of that loop, where do we go back to? We have to go back to line 5. Okay. So, line 5. Because we are talking about this loop here, from line 5 to line 8. This end while matches the indentation of that while, and that visually tells me where I'm supposed to go back to. Are we doing okay so far? Okay, so going back to line 5, we re-evaluate y is less than 2. It is still true because y only has a value of 1 at this point. Then we go to line 6 again, it increments to 2. We go to line 7 again. We are adding 1, 2, and 0, so we have a sum of 3. And then where do we go again? We're back to line 5, and that condition is now false because 2 is not less than 2. Where do we go next? Wait, hold on a second here. Line 5 to line 8 is considered a single statement. It can be seen as one single statement that has nested statements inside. So we are now ending that loop. Line 5 to line 8 as a loop is now done. Where do we go?
Line 10.
Line 9. Okay, there is a statement after line 8, so we now go to line 9. All right, line 9 is adding 1 to x. X goes from 0 to 1. Now we are at the end of another loop. Where do we go next? Back to line 3, because the end while of line 10 has the same indentation or the same nesting level as line 3. So we now go back to line 3, which re-evaluates whether x is less than 3. It is still true. And then where do we go? Line 4 again, and so on. Okay? Wow, that's kind of complicated. How am I supposed to remember this? Well, one thing you can do is to look at the picture. Yeah, it took me a little bit of time to draw that. But the picture tells you something about the structure of the code. If you focus on this part here, does that part look like a pre-checking loop to you?
Yes.
And that's our inner loop. That's not line 5 to line 8 is the inner loop. When you look at the outside one, you can see, now when you look at the outside loop, you can consider this inner loop here as one single thing. It's one single statement. But it has the same level as y gets 0, as well as x gets x plus 1. So inside the outer loop, okay, I'm talking about the outer loop from line 3 to line 10, it has one statement, two statements, three statements. That's from the perspective of the outer loop. Except that the second statement by itself is also a loop, has its own internal two statements inside it. But this is the picture corresponding to the pseudocode that we were tracing. So the exercise for you guys to do is not just to do the chore and finish tracing the program, which is important, okay? Because the more you do it, the more you ask, okay, where am I supposed to go here from here? The more you're thinking and reminding yourself how to handle nested loops. But your task, as you are doing that, is to mentally map the pseudocode to the picture or the logic that it is actually representing. That really is the important part of this class, is to map pseudocode to the actual logic that it is representing. Do we have any questions about this part? I'm not done with the trace yet. We will finish it on Thursday. But before I finish it in class, you might want to do it by yourselves so that you can at least give it a try. And then on Thursday, you can see if your answer is the same as the answer that I will give you on Thursday. Yep.
Is that our homework for
I will give you an assignment homework. I will send an email to you when it's done, when it's up. Yep.
Professor, I saw the email you sent me about the admin.